Hello, welcome to the module of building strategy, and in this video we are going to learn about the building strategy for complex systems with integrations distributed system. In this video we are going to focus first on an overview of complex systems, then we would be lap around a distributed systems overview, then we would be talking about the features of distributed systems followed by the top observability strategy for distributed systems. So let's get started. A complex system is basically termed as a system which is composed of many components that may interact with each other. Complex systems are the systems whose behavior is intrinsically difficult to model due to the dependencies, competitions, relationships, or other types of interactions between their parts or between a given system and the environment. Now there are five different kinds of attributes that we can call as for the complex systems, which are being termed as the hierarchical structures, relative primitives, the separation of concerns, the common patterns, and the stable immediate forms. Now let's talk about a feature of the distributed system. So what do we mean by a distributed system? Now a distributed system should easily connect users to the resources so that it should hide the fact that the resources to be distributed across the network that should be open and must be scalable. Now while we have been defining about the distributed systems, so the main goal of the distributed system, that's to connect the users and the resources. So we should talk about that as far as the goal of the distributed system, it should be that's to make it easy for users to access the remote resources and to share them with the other users in the controlled manner, so that resources can be virtually anything. Typical example of resources that could be like printers, the storage facilities, the data files, the web pages, and the networks. And there are many reasons for sharing the resources, and one of the main reason is called as the economics. Now we can also talk about like the transparency, how the transparency could affect in terms of our distributed systems definition. Now as an important goal of the distributed system is basically to hide the fact that its processes and resources could be physically distributed across the multiple computers. So since the distributed system, which is being capable for presenting itself to the users and the applications such that it is only a single computer system, which is being called as a transparent one. So basically this kind of transparency actually being referred to as like as a collection of autonomous computer systems that have been physically separated but are connected by a centralized computer network which has been equipped with the distributed system software. And these autonomous computers will communicate among each others by sharing the resources and files and performing the task which has been assigned to them. Now we should talk about now the features of distributed system. So one of the main features for the distributed system that we can talk about, which have to be defined in terms of like the resource sharing feature, because that is one of the major important goal for the distributed system. It should have the ability to use any kind of hardware, software, or data anywhere in the system. A distributed system should be also must be an it should have the facility of openness. Means another important goal of the distributed system that is being termed as the openness. So an open distributed system is basically it's a system that offers the services in the standards that describes the syntax and the semantics for those of the specific service instances. Now the standard rules in the computer network which can control the format, the content, and the meaning of the messages that should be sent and the received itself. Now such rules could be formalized in such a way that it should be termed in terms of protocols. Now in distributed systems our services has to be typically specified through the interfaces, so often which has been termed as the interface definition language or IDL. These interface definitions which has been written in IDL are almost captures only the syntax of the services, so they accurately specify the names of the functions that are available with the types of parameters, the return values, and the possible exceptions which can be raised and so on. Now we can also define it in terms of scalability aspect, because the uncertain trend in the distributed system is towards like the larger system. Now this observation has the implications for the distributed file system design. So like the algorithms that work well for the systems with 100 machines can also work for the systems with 1000 machines, and none at all for the systems with 10,000 machines. Now for the starters, the centralized algorithm may not scale well. So just by opening a file, it requires like contacting a single centralized server which can record the fact that the file has been opened, and the server will eventually become a bottleneck as the system grows. And we can also define that in terms of concurrency, because it's naturally present in the distributed system, and the deal with like some activities or functionality is that it can be performed by the separate users who are in the remote locations. Now every local system has its independent operating systems and the resources. So we should have like the proper reliability aspect, because the main goal for building the distributed system is to make sure that it has to be more reliable than the single processor systems. So the idea is that if some of the machine goes down, some other machine get used to it. So theoretically that this reliability of the overall system could be a Boolean value, or it could be like a based on the component reliability. So for all of the 4 file servers, each of which having like 0.95 chances of being up at any instant, the probability for all the 4 that is being down simultaneously is like 0.006. So probability of list 1 being available to 0.99994, which would be far better than individual server. Now we can also talk about in terms of scalability aspects, because the features of distributed system actually implies that the performance also increases the scale of the system as the number of processors communicate with more users by accommodating to improve the responsiveness of the system. So it also cares about like the reliability of the system, because building a transparent, a flexible and reliable distributed system is useless if it is slow like a molasses. So in particular application on a distributed system, it should not deteriorate better than running some application on a single processor. So there should be like various performance matrices could be used for. Response time is one, but it is more like towards the throughput. So like it can include that system utilization, the amount of network capacity that it could be consumed over, and furthermore the results of any particular benchmark, that is also it could be highly dependent on the nature of the benchmark. So a benchmark that should involve like a large numbers of independent, highly CPU bound computation that could give like the radically different results than the particular benchmark that consists of like scanning a large file of some particular pattern. Then we should also talk about the transparency option. So transparency that also comes in terms of that the distributed system should also must be able to hide the complexity of the distributed systems to the users and application programs, so that there should be a privacy in every system. So as a core features of distributed system, it should have the particular features like concurrency, which should provide the shared database accesses. It should have the features of the failure handling, where it can hide the fact about the resource failure. It should have the features of the persistency, like where it can hide the fact about the memory location. And it should have the features of the relocation, that where it can hide like the moved place relocation, or migration feature, like where it can move the place information, or location, where it can hide the location altogether. Now, what are the top observability strategy for distributed system? Our distributed system should be also able to capture or aggregating all sorts of application logs. It should be able to track the application matrices like the CPU status, its disk usage, or like the memory matrices, memory usage, overall disk IO, latency, network latency, all sorts of application matrices like application performances, it should be able to capture over. Similarly, the distributed systems, as part of the observability strategy, it should be able to log the audit data, so that the typical auditing features like the logs, that is the kind of logs that we want, that it should be stored over, like the user sign-in logs, or like we could call it like a network access logs. So that kind of all those features that as part of the core characteristics of the distributed systems like scalability, concurrency, heterogeneity, replication data, it should be all must need to have a proper logging facility. And similarly, we should be able to perform the distributed tracking. So like since like it should have a distributed system consist of multiple nodes which has been working together in a loosely coupled architecture. Now if one of the node fails, the remaining nodes can continue to operate without disrupting the overall computation. So similar to that, we should be able to perform the distributed tracking on this versatile heterogeneous nodes, and we should also be able to keep track of the changes and the deployment initiatives. So in that cases, like while we have been applying the heterogeneity, like most of the distributed systems, the nodes and the components are often that is to be termed as an asynchronous one. So with like different sets of hardwares, middleware, softwares, and the OS, so that could allow the distributed systems to be extended with the addition of new component. And similarly, that it should have distributed systems always have the facilities to understand the anomalies and the replication, because distributed systems should enable like the shared information and the messaging, which should ensure that the proper consistency between the redundant resources such as software and hardware components, improving the fault tolerance, readability, and the accessibility. So that is altogether which has been termed as a distributed systems observability strategy, where we should also have a kind of distributed tracing facility, because distributed tracing, as we know, it is being sometimes being termed as a distributed request tracing, which is the method for monitoring the applications, typically those that has been built on a microservices application or microservices architecture, which has been commonly deployed on the distributed system. Distributed tracing is essentially a form of distributed computing in that it has been commonly used to monitor the operations of applications running on the distributed system. Distributed tracing is also necessary because of the considerable complexity of modern software architectures. A distributed tracing system is being designed to operate on the distributed services infrastructure, where it can track like multiple applications and can process the simultaneously across numerous concurrent nodes and the computing environments. So that was like in this video we have also talked about in detail about the distributed system components, that's the features of distributed systems, the benefits of distributed systems, like in terms of greater flexibility, because since the distributed systems provides an easier options, that's to add more computing power to the need of services. In most cases today you can add more servers in the distributed systems on the fly. It's reliable, it has got most enhanced speed because heavy traffic can bog down the single servers when the traffic gets heavier, impacting the performance for everyone. The scalability aspects of distributed databases and other distributed systems also make them easier to maintain and to sustain the high performance level. And geo distribution, like distributed concurrent delivery, is also, it has been both initiative in terms of internet users and vital for global organization. Now today in all sorts of applications, like while you have been working on cloud computing, like for example in Microsoft Azure, you have been started to working with as a public cloud vendor, and you have been going to apply on any of these particular resources, that's the concept of distributed systems. So you'd be able to see that even in all sorts of public cloud, private cloud, the nodes and servers or storage, that's are all based out of the concepts of distributed systems. Say for example in data storage, you can store over the virtual servers, that's object based data storage, file shares, or like a real-time messaging based storage like a queue storage, or even like a non-RDBMS compliance like a database storage, that's in the table based storage facilities. So that is like in all our modern cloud computing, or even like our container based systems, that's are all based out of, or even like big data clusters, that's are all based out of the distributed systems components and the distributed systems architecture. So in this video we have defined in detail about the overall features of the complex systems as well as the distributed systems definition, the core features of distributed system, the benefits of distributed systems. I hope this video has been informative for you, and I look forward to see you in the next video. Thanks for your time.